First of all, let's recap the difference between a series and a sequence. A sequence is simply a list of terms like 2, 5, 8, 11, and so on. A series is the sum of a certain number of terms. For example, 2 plus 5 plus 8 plus 11, and so on. This series can be finite and have a set number of terms, or it can be infinite and go on and on and on. There's some notation that you need to remember. The first term of an arithmetic sequence or series is denoted by the letter A. So here, A equals 2. The second thing you need to know is that the common difference, that is what you add or subtract each time, is represented by the letter D, and in this case it is 3. So for example, the second term here, which is 5, is the first term plus 1 difference. And we might label that with a T and a lowercase 2 or a subscript 2 like that. Term 2 is the first term plus 1 difference. We also often see the letter U to represent the terms as well. Term 3 is the first term plus 2 differences. Term 4 is the first term plus 3 differences, and so on. From this pattern, we can see that the nth term, let's call that T with a subscript n, is equal to the first term plus n, that's the number of terms, minus 1 multiplied by the difference. So if it's the second term, there's 1 difference. 2 minus 1 is 1. If it's the third term, there are 2 differences. 3 minus 1 is 2, and so on. Here we have the formula for the sum of an arithmetic series. This can be found in the formula booklet, but we're often asked to prove it. So we start by writing the sum of the series is equal to the first term, which is A, plus the second term, which is A and 1 difference, if you remember, plus the third term, which is A plus 2 differences, and so on, until we get to the last term, which is A plus n minus 1 differences. And now we write this out again, but in reverse. So the sum of the series is equal to this last term here, which is A plus n minus 1 d, plus, and if we were going in reverse order, we'd have the first term plus n minus 2 lots of the difference, plus A plus n minus 3 lots of the difference, all the way up to the first term, which is A. Now what we want to do is add each term together. Remember, each of these has the same number of terms. They have n terms. So if we take this term and this term and add them together, and the same on the left-hand side. So the left-hand side, we end up with 2Sn. That's the sum of the series twice. And then here, A plus A is 2A. And then we've got a plus and n minus 1 d. And actually grouping the next 2 terms, so that's all of these, we'll get the same result because we get minus 2d plus a d. So that's 2a plus n minus 1 d. And then we get the same again with the next terms. 2a plus n minus 1 d, and we can see that this last one here is the same as the first one. Plus 2, oh, must put the ellipses in, plus 2a plus n minus 1 d. Now this repeats n times, so now we can write that 2 Sn equals n lots of 2a plus n minus 1 d. And then to get the final result that we're looking for, we need to divide both sides by 2. So s to the n equals n over 2, dividing both sides by 2, brackets 2a plus n minus 1 d. And there we have the result that we were looking for. Now it's worth noting that the last term in the sequence, that's this one here, can be written as the letter L. And we could say that L equals a plus n minus 1 d. So if we know the first term and the last term, we can use the formula s to the n equals n over 2 brackets a plus L. This is a useful formula to remember.